Imagine a computer so powerful it could solve problems in seconds that would take the fastest supercomputer millions of years. What might this mean for the future of computing? Traditional computing, as we know it, is reaching its limits. Classical computers, bound by the laws of classical physics, are only able to process bits of information in ones and zeros. But what if we could transcend these limitations? What if we could tap into the strange world of quantum physics to create a new breed of computer? Enter quantum computing. Unlike classical computers, quantum computers use quantum bits or qubits that can exist in multiple states at once. This allows them to handle vastly more information and solve complex problems at speeds that are currently unimaginable. The implications? Groundbreaking advances in medicine, a revolution in artificial intelligence, and the potential to crack the most complex cryptographic codes. This isn't science fiction. Welcome to the world of quantum computers. But what exactly is a quantum computer? It sounds complex, doesn't it? Well, let's dive into the world of quantum computing, but don't worry, we'll keep it simple. At its core, a quantum computer is a new kind of machine that uses the principles of quantum mechanics. Now you might be thinking, quantum what? Quantum mechanics is the theory that describes the nature and behavior of the tiniest particles in the universe, like atoms and photons. In the world of quantum, things can exist in multiple states at once, thanks to a principle called superposition. Imagine you're in a room with two doors. In our everyday world, you can either be behind door number 1 or door number 2, but not both. However, in the quantum world, you could be behind both doors at the same time. This is the concept of superposition. Now let's add another principle called entanglement. If two particles are entangled, they become linked. So if you change the state of one particle, the state of the other changes instantaneously, no matter how far apart they are. Imagine having a pair of dice. When you roll one, you instantly know the outcome of the other. That's entanglement in action. So, how does this compare to our traditional computers? Well, traditional computers use bits which can either be 0 or 1. In other words, they're like a light switch that can only be on or off. Quantum computers, on the other hand, use quantum bits or qubits. Because of superposition, a qubit can be 0, 1 or both at the same time. It's like having a light switch that can be on, off or both simultaneously. This allows quantum computers to process a vast number of possibilities all at once, which could potentially revolutionize fields like cryptography, medicine, and artificial intelligence. So unlike our traditional computers that work with bits as 0s or 1s, a quantum computer uses quantum bits or qubits that can be both 0 and 1 at the same time. This is where the magic happens. So we've taken a glimpse into the fascinating world of quantum computers. We've seen how they hold the potential to revolutionize computing, making calculations at a speed that leaves traditional computers in the dust. The principles of quantum computing based on quantum bits or qubits allow these machines to process vast amounts of data simultaneously, a feat unattainable by our current computing systems. We've also seen how quantum computing differs from traditional computing, introducing a whole new paradigm where bits can be in multiple states at once thanks to the principle of superposition and can be intertwined due to entanglement. As of today, quantum computing is still young, with companies and researchers worldwide pushing its boundaries and exploring its vast potential. While we've made significant strides, there is still much to uncover in this exciting field. Quantum computing is still in its infancy, but its potential is colossal. As we continue to unravel the mysteries of the quantum world, who knows what the future of computing might hold?